Problem 21 says the number of moose in a national park is modeled by the function m that satisfies the logistic differential equation dm dt equaling 0.6m multiplied by the quantity 1 minus m over 200, where t is the time in years and m of 0 is 50. What is the limit as t approaches infinity of m of t? To get through this problem, you really don't need to know a ton. You do need to know that if they say that m, which means the number of moose, or meese, I don't know, moose, anyway, and they say it's a logistic differential equation, then basically what that means is that the population function is a logistic growth function, and you would need to know what the shape is of a logistic growth function. So let's talk about that. So basically, if I was to graph m, or m of t, where m is the number of moose, then basically you have a population that starts out being, you know, a happy population that grows exponentially, and then at some point we find out there's only so much. I don't know why I drew a negative axis for that vertical axis, but whatever. We find out that there's only so much like resources, I guess, in this national park. And so at some point the population starts kind of slowing in growth, but then it has a horizontal asymptote representing kind of that upper capacity of population. So this is the basic shape of a logistic growth function. And so one way to get through a problem like this would be to know that whatever this like carrying capacity is, so that would be the limit as t approaches infinity of m of t. So that would be this, whatever this population is up here. You know that dm dt equals 0 here. And so what I would do to figure this out is just put 0 in for dm dt and solve for the m values. And so let's show what that looks like if you do. So we just put 0 in here. And then we could just solve for m. So m could have been 0, which kind of makes sense for this bottom piece here. But that would be the limit as t approaches negative infinity. And then the other m value would be whatever it takes to make this part be 0, and that would be m equaling 200, like so. And so I would say that this line right here would be m equals 200. There we go. Hopefully that makes sense. So the answer should be B.